Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, faculty members across India, initiated by myself in 2017, and we used to organize online problem solving sessions to help the students who prepare for different national level competitive examinations like CSIR, NET, GATE, IIT, JAM, etc. As a part of that online problem solving session series, today we blessed to have Mr. Lalit Tuval, a research scholar from IISc Bangalore, with us to have a discussion on CSIR NET examination. He will explore one of the previous year question paper uh, today and tomorrow's session. That will be definitely very helpful for anyone, those who are seriously preparing for the forthcoming examination, which is going to happen very soon. Yeah, in the third week or fourth week of July. So I would like to express my sincere gratitude and thanks to Mr. Lalit for being with Math Aspirants and for helping the math students to pursue their dreams. I welcome everyone to this program. Welcome, Lalit.
Thanks for the kind introduction and giving the opportunity to discuss CSIR NET mathematics paper with CSIR NET aspirants. Okay, so before I start, students, today we will solve selected problems from the CSIR NET last exam 2024. So there are two exams in the 2024. So you know that one exam was held in the Assam separately later, and one exam is for all India, right? So we will discuss today the selected problem from that exam. So before starting the session, I would like to share a source with you that will really be helpful for you to boost your preparation. So let me present my screen. So if someone of you will confirm that if you can see the screen. Can you see the screen?
Yeah, the screen is visible.
Yes, sir, you are visible.
Yes, sir.
Okay, thank you. Yeah, so as you know that the CSIR NET exam will be, around 26 to 28 July. So you must have been solving the CSIR NET previous year papers and will have been solving the CSIR NET PYQs for next 25 to 26 days, right? So here you can search in YouTube in mathematics and go to the home page. You will get here the complete playlist of CSIR NET mathematics solutions. These are very detailed solutions and every question is discussed in very detail. And I have also told the shorter way to solve the question. So here, the July 2024, December 2023, June 2023, the complete playlist is there. Okay. So also in some days, the CSIR NET 2025, December 2024 playlist will also be displayed here. Okay. So you can explore the solutions and watch the solutions here. Okay. So let's start. So let me join from the another device and present the screen of that. So give me 1 minute, okay? Yeah, also I want to let you know that not only CSIR NET solutions, but also you can watch, these are free solutions, okay? Almost all are free there. So these TFR solutions, CMI solutions, and ISI solutions, if you have already solved the NET examination. So these solutions, these solving these questions will also be helpful for your NET examinations, okay? So yeah, okay, let's start now. So can you see the questions on your screen?
Yes, sir.
Okay, so let's proceed, okay? So this is question from CSIR NET December 2024. All these questions are from either CSIR NET December 2024 Assam paper or from the original one, okay? So, and I have selected from almost each area. So let's start. The first question says that let xn be a sequence of real numbers that has a decreasing subsequence. Assume that this subsequence converts to the number 2025. So which of the following statements is necessarily true? Okay, so let me tell you results. that two results. Okay, so keep remember this, that limit infimum is smallest limit point if exist. Okay, otherwise it would be infinity or minus infinity. So limit supremum is what? Can you tell me? Limit in supremum is greatest limit point. Okay, so what do I mean? I mean that if you collect all the limit points in a set, then of a sequence such that there exists a subsequence which converts to L. Okay, roughly. So I mean, I'm writing this roughly. Then the supremum of this set is limit supremum and infimum of this set is limit infimum. Okay. So what this says, so we know that there is a limit point. I mean, 2025 is a limit point of. So the information tells us that 2025 is a limit point of xn. So can you conclude now? I mean, use these result and conclude which one is correct and raise your hand. Okay, very good. Okay, Gopika, which one is correct?
The third one.
Okay, very good. So, see, limit infimum xn can, it says that greater than or equal to 2025, right? This is wrong because you can take this one, 2025, 2024, 2025, 2024 like this, okay? This limit infimum of this sequence is 2024, right? Because we have a sequence which converts to 2024 also, and there are only two limit points of this sequence, okay? So the first one is wrong. I mean, this is the counter example. And the limit supremum must be less than or equal to, similar example can work, right? Similar example, not the same example, okay? Similar example means just replace 2024 by 2026 or a favorite number which is greater than 2025, strictly greater than 2025, okay? So this is also wrong, right? And this says that the limit infimum must be greater than 2025. This is obviously wrong because the information letting us know that the smallest limit point, limit infimum, must be less than or equal to 2025, right? Because we have a limit point 2025. So the third one is correct, the fourth one is wrong. Okay, is there any question? Yeah, what question? Ask. No question.
The
Okay.
subsequence is decreasing.
That doesn't matter. But let it be increasing, let it be decreasing. It says that 2025 is a limit point, right? Okay, and we have used only that. So let's solve this quickly, okay? So see, if you want to score good in CSIR NET exam, then you must have to solve the questions very quickly. Okay, you should have way to solve the quickly the questions, right? Because even if you know the solving the questions, I mean, you take some longer time, that you will not be able to score good in the CSIR NET exam. Okay, so you have to practice a lot. You should know the results, and the results should be in the tongue. Okay, so that you can use them appropriately and solve the questions quickly. All the questions in part B are very easy to solve if you know the right way to solve them. Okay, sometimes you may use a long approach that should not be done. I mean, a better approach works there, so that must be learned. Okay, so see here what it says. So you can solve this question in the exam in a blink of eye. How? What it says, that we have a linear transformation R4 to R, and this satisfies these two equations. Okay, so it means that the minimal, we want to know about the eigenvalues. Okay, see that this says that diagonalizable over R, this is that characteristic polynomial, this asks about the characteristic polynomial. So and this says that the T commutes with every linear transformation. I mean, in other words, that S T is a scalar matrix or scalar linear transformation. Okay, so we would like to know the eigenvalues. How can we know? By the minimal polynomial, right? Every eigenvalue is a root of minimal polynomial. Okay, so minimal polynomial will divide these two polynomials, x square plus, because these are annihilating polynomials of T, right? Minimal polynomials divides every annihilating polynomial. You should know that. X plus 1 whole square, x, let me factorize, okay? I mean, let me adjust according to my convenience. So this polynomial comes from here, and this gives this, right? The minimal polynomial will divide these two polynomials. So mx should divide what? GCD of both these polynomials, right? This one and this one. But the GCD comes out to be, let me know, x minus 2. Okay, and so this says that minimal polynomial is a non-constant polynomial, right? Only non-constant polynomial dividing x minus 2 is the x minus 2. It means the minimal polynomial is x minus 2. T will satisfy this. So this comes out to be this. So it means T is 2i. This is a scalar matrix. So keep in mind that we have been, yeah.
Why mx should divide x plus 1 square into x minus 2 into x plus 2?
Because of this. Because this is an annihilating polynomial, right?
Sir, x plus 1 square is not x square plus x plus 2, right?
Yeah, oh, sorry. I'm really sorry. Okay, so thank you. Yeah, this is this, right? Still this is irreducible, right? Whatever we, but the roots of this are not 2 and
That
omega and
should
omega
be
square.
x square plus x.
X square plus
Sir, that should be x square plus x plus 2,
x
right?
plus 2. Okay. Right. So still the GCD comes out to be x minus 2, right? Because these two has no common roots, right? So is it clear to everyone now? Okay, thanks for the correction. Okay, so T is diagonalizable over R. This is true because every scalar linear transformation is diagonalizable. Let me write true and false here. Okay, so the characteristic polynomial is obviously x minus 2 to the power 4, and the characteristic polynomial of T is right. This is not. I mean, this is false, right? And scalar transformations commutes with every linear transformation. That is true. So this is also true. So we have solved it. Okay. I mean, this is very easy to solve in the exam, right? Yeah. Okay. So the next one. Let's solve some applied questions. Okay. So can you solve this? You can try. I mean, you have to do it quickly. Okay. That's why I'm asking that. Can you solve it? Not more than 1 minute. Okay. So which one is true? There is only one hand raised, so let me know which one is true.
Option 1.
Very good. Option 1 is true. Okay, so let me tell you how. Okay, so see. First of all, we will use here the existence and uniqueness solution. Okay, you all know that, I think. So dy by dx is equal to this. This is obviously continuous, right? If you take a rectangle, and also Lipschitz with respect to y, because sin y is Lipschitz. Okay, if you take the derivative, I mean, of this function, del f by del y, this comes out to be cos y, right? And this is locally Lipschitz. Okay, if you will consider a rectangle, then del f by del y will be bounded there. Okay, with respect to y, this is Lipschitz. So the solution exists because of the existence and existence theorem. Now, and it will be unique also. But how to find the maximal interval of existence? That is very easy to find. See, so if you take the rectangle x minus 1 less than or equal to L, A, let's write A here, and y minus 0 is less than or equal to B. So your dy by dx comes out to be mod. So let me know its bound. What is the bound of this?
Root over A.
Okay. Root over it. And the maximal, I mean, if the existence of interval is like this, then how the h is found? Maximum of or minimum of?
Minimum of.
Minimum of root A, sorry, A, comma B over this function, right? This bound. Okay. See, B and A are in your hand, right? Okay, so what will you take B? I mean, what can you choose in place of B such that you get solution exist in every interval of the form, like 0 minus something or 0 plus something? Let me know. What should you choose in place of B? It's easy, right? Just choose a to the power 3 by 2. So this will tell that minimum of a comma a. It means h can be any number. This shows that solution exists in every interval of the form. So this exists for in R, right?
सर
Okay.
आपने जो इंटरवल रेक्टेंगल डिफाइन किया हुआ है वहाँ पे सर वो इनिशियल कंडीशन y माइनस 1 के साथ भी होना चाहिए ना सर?
y minus 1 नहीं
आपने
आएगा.
सर x माइनस 1 लिखा
Oh,
वहाँ
y
पे
minus
इनिशियल
1.
कंडीशन.
Okay, fine. But still काम यही करेगा मेथड. मतलब थोड़ा सा एडजस्टमेंट आ जाएंगे कैलकुलेशन में. जो मैंने बोला होगा ऐसे ही. ठीक है, ये आप लोग सुधार लेना. Okay, so students, I mean, I made a calculation mistake, so you will correct it. Okay, but the same method will work because this bound comes out to be independent of B, and that is helpful actually. So every time, I mean, in previous years, such kind of questions also have been asked, and I have solved those questions in detail. Some of you might not have understood, I mean, what I mean. So you can check in the playlist, okay, what I have told in the starting of this session. Okay, so the first one is true. Okay, so let's solve this one. So this is Cauchy-Euler equation. Okay, and this question should also be solved in the exam, and this can be done very quickly. If you have the practice, then you can solve it very quickly. Okay, so how to solve this? So you must know that we transform it first to this first to the equation, differential equation with constant coefficient. So with this substitution, what is the substitution we use? Can you tell me? What substitution we use?
2x plus 3 equal to e to
3
the power z.
1 x.
I think we use this, right? Or 2x plus 3 equal to e to the power z.
2x
What
plus
we
3
use?
equal to e to the power z.
Okay, so 2x plus 3 equal to e to the power z. So the equation is transformed to? What will be the transformed equation?
So
Yeah, let me
1
know.
by
So 1 by 2 d2 minus d plus 1 by
Okay.
2.
D into d minus 1. Here d will be, d or d by dj.
Yeah.
So this will comes out to be, okay. So I'm not going to the, intermediary steps. Okay. So let me know if I'm wrong somewhere. So this comes out to be this. Is it okay?
Yes.
You can verify this. Okay. So now let's divide it by 4. Okay. Then we get d into d minus 1, 6, 3d, and here we will get 2 equal to 0. No, auxiliary equation will be m square plus 2m plus 2 equal to 0. So the roots of this equation is minus 2 plus minus b square. B square means 4, and here 8, right? 2. So this comes out to be minus 1 plus minus I, right? The solution will be then y equal to e to the power minus 1 real part cos z. Here e to the power minus z, okay? Cos z plus sin z, okay? But with our substitution, this comes out to be e to the power minus z means this, right? And cos z, z equal to, let me know, log 2x plus 3. Sin 2x plus 3. Log 2x plus 3. Okay. So you can also solve with me, okay? Right. Now, what we need to find? We need to find the set of zeros, the cardinality of set of zeros of this set. Okay. And x comes from the positive real numbers. So if this is 0, yx is 0, this means this is 0, right? So either this one 0 or this one is 0, right? So this is 0 for, is this 0? No, this is never 0, right? Okay, so this must be 0. So cos y plus sin y is 0. I mean, let's assume t here, okay? Zero means that whenever 10t is minus 1, right? And 10t is minus 1 has how many solutions? Countably many, right? And assume when I'm saying 10t, then I'm not, I'm assuming, okay, sin t is not 0, okay? So has countably many solutions. How you can see it quickly? Let me tell you. Okay, so see, the graph of 10t looks like this. Okay, this is the line pi by 2, 3 pi by 2, and all, minus pi by 2, minus 3 pi by 2, and this is 0. So the graph looks like this, right? I mean, it may not look exactly like that, but roughly it's like this. So in each interval of kind like this 0 to 5 by 2, pi by 2 to 3 pi by 2, or okay, so I think I made it wrong. Okay, so it will look like this. So it will pass from 0 and like this, right? Do you understand?
Yes.
Yeah, okay. So see, minus pi by 2 to pi by 2. So you just need to look at this interval first. So if you draw the line minus 1, then here the graph of 10 cut it at once. Okay. Similarly, the graph of 10 in the other interval of this form will cut at once. Okay. So in this way, we have countably many points, right? You can count them 1, 2, 3, and all. Yes or no? Is it clear?
यस सर, यस सर,
हाँ.
एक क्वेश्चन है इसमें, अगर साइन टी इक्वल माइनस कास टी,
हाँ.
then both graph sin x and cos x, then the countably many
हाँ,
cut,
हाँ.
तो वहाँ
वैसे भी कर सकते हैं,
वैसे
बिल्कुल ठीक है. हाँ हाँ, बिल्कुल सही है, वैसे भी कर सकते हैं. आपने ठीक कहा, आप ऐसे भी जा सकते हैं. ओके, यू जस्ट हैव टू सी द इंटरसेक्शंस. ओके, तो साइन का ग्राफ ऐसे चलता है, तो आपको क्विकली रियलाइज कर
Yes.
लेना है, बस काउंटेबली मैनी होता है और कॉस का ग्राफ ऐसे चलता है. ओके, अब राइट, ये भी यहां से भी क्लियरली दिख रहा है कि काउंटेबली मैनी इंटरसेक्शंस है, राइट?
Yes.
Is it okay? Yeah. And this 2x plus 3, ये यहाँ पे मतलब किसी भी वैल्यू को ले सकता है. ओके, लगभग. This is the onto function. Okay, so you can make all those calculations. So let me leave it for you. So the answer would be SH a countably infinite set. But in the exam, you should be able to solve this kind of questions very quickly, okay? Because all these kind of things you have already seen, right? Because there was a question in December 2018 which asked that the fixed point of 10x, right? See in the part B of December 2018, if I remember correctly, then you will see a question. Then from there, you already know that. Okay, so that's why this comes to my mind. Okay, not this one. Okay, so one can solve in any way. Okay, that's fine. So let's move the next one. This one, and this is the part C question. Okay, and this must be solved very quickly. So first, you all try to solve it in a 2 minutes. Then I will let you know how to solve this quickly. Could you try? Yeah, okay, then try. Let's start.
Sir, question not visual.
Yeah, okay. The font is small. Size is small.
No, sir.
So what's the problem then? Can't you see the screen clearly? Now can you see?
It is visible for me. Maybe he has a net issue.
Yeah, okay. So I would like to confirm it. अभिलिप्सा दिखाई दे रहा है क्या?
Yes, sir.
Okay, so all can see. So raise your hand, okay, if you have solved it. Okay, very good. So which one is correct, Avilipsa? So you raise the hand first. So let me know which one is correct.
1 and 4.
1 and 4. So you think that the fourth one is uncountable. Why the fourth one is uncountable? The region? What is the region for that? Okay. So Riddhi, the fourth one is correct?
Yes, sir.
Okay. You think that it's uncountable. Okay. So Sayan, is it uncountable?
सर मुझे नहीं लगता.
Okay. Dasrath, What do you think? The fourth one is uncountable?
Yes, sir.
Okay. Gopika, what do you think? The fourth one is uncountable?
No, sir, I think it's countable.
Okay. Why do you think that it's countable?
Because when I thought if the square of a number is rational, then that number will also be rational. So
No, no,
we
no,
know that rational.
no. But it's not like that. If you square root 2, then you get also the rational number. So you must misunderstood,
sir.
I think. Yeah, okay. So
I'm not gonna.
anyone who says that this is countable and can, I mean, give the arguments, anyone can go ahead.
Yeah,
Sir,
the fourth one has to be countable.
Okay, why?
Fourth one has to be countable because each rational number has at most two square roots in the real
Ah,
numbers. So in the
right.
set of rational number is count.
Okay. Fine. Very good. Very good. Right. So all you understood now that why that comes out to be countable? Because each rational number has at most two square roots, right? In the rational number. So that must be countable. Right? Okay, I will let you know why. Okay, so see. So, dekho. For a real number x, I will tell you the way, okay, how you can, eliminate the options quickly. How can you solve it quickly? So try to understand. So this is the largest integer, less than and equal to greatest integer. Which of the following sets are uncountable? The first one says that the greatest integer of those number, which is 1, this is, right? This is 1, 2. So this is obviously uncountable, right? So we have solved it very easily. The second one says that the fractional okay, there are two ways to solve this question. Okay, first, I mean, you can solve it in mind. No need to draw anything. You can just think that, okay, how the graph of fractional part looks like this, right? Just think in your mind, and this can be thought very quickly, right? So, and the line y equal to 1 by 2 passes like this, right? So how many intersections are there? Countable? Yes or no?
Uncountable, sir.
So where are the uncountable intersections? I don't think that there are uncountable intersections. So these are countable, right? And these are also countable. Countable union of countable sets is countable, isn't it? Okay, this is countable. Okay, otherwise, just think like that. X is of the form 1 by 2 plus greatest integer part, and X belongs to Q, and any subset of Q is countable. I mean, there is other way also of solving this. No need to look at graphs, right? So this is a subset of rational number, and any subset of rational number is right countable. So, and the third one, it says that X is greater than or equal to 0 and root of X belongs to C. Then root of X means this will look like PQ for some PQ, right? For some PQ, okay? So Q should not be 0, you all know that. And X is then P square and Q square. I mean, this, we know that again comes out to be a subset of Q. It means it's countable, right? Okay.
yes.
And yeah, and the last one, it says that the X square belongs to Q. It means that X comes out to be something like this. So us, and let me write this set, okay? Okay. Anything else is there?
Yes.
So you can see that this is countable, right? How can you see? Just fix P, okay? For, these P's are countable. For each P, you get a countable set. Yes or no? Fix P, take P equal to 1, P equal to 2, okay? Don't take the negative one, okay? I mean, I have wrote here wrong. You can't take the negative. You should. Do you understand?
Sir, for
I
validation. Okay.
Yeah, because you need the real number, right? So now, is my voice clear?
Yes, sir.
Yes.
Okay. Yeah, okay, thank you. So see, take P equal to 1. For each P, you get a countable set, right? And you can write, I mean, say for each P, you get the set SP, and you can write this set as a like this. P belongs to N. And the countable union of countable sets is countable. And the other way, that one of the students just said that at each rational number has at most 2 square roots, so the set comes out to be countable, right? Because you can fix each rational number. For each rational number, you are getting at most 2, right? Suppose that you have a rational number R. You are assigning this rational number two numbers, okay? Like this. R1, for R1, you have at most 2, okay? I mean, there may be nothing in place of Q2 and Q1 also. So all rational number can be listed like R1, R2, dot, dot, dot. So do you think that the fourth one is countable? Yes or no? Yes or no? Yeah. So you are done. So this kind of question solved very quickly in the exam, okay? So that you score very well. And you should have a very right approach to solve, because many of you may waste time to solve. I mean, you may approach in a longer way, okay? So be careful of that. Yeah. Okay, so let's solve this one. Okay, so this one also can be solved very quickly, and this is a part C question. Okay, and you can grab 4.75 marks in just seconds. I mean, it will not take more than the time of reading. Okay, let's start together. Okay, so it says that for each n greater than 1, we denote the C vector space of all n cross n complex matrices. It means that V equal to, you must be familiar with this notation. And A is a matrix, complex matrix. Which of the following are necessarily true? Okay, the first one says that this set is linearly dependent. All you know that we have the characteristic polynomial of each matrix. Let's denote it by Cx. This is a n degree polynomial, right? N degree monic polynomial. And the Cayley-Hamilton theorem says that Cayley-Hamilton theorem says that each matrix satisfies its characteristic polynomial, right?
Polynomial.
Yeah. Okay, so this shows that this set is, let me know. I have not read yet the options, okay? So all the options are asking about the linearly independence of this set and all. So the first one says that this set is linearly independent. So this is completely wrong, right? Yes or no? And if you read ahead, the set this is not linearly independent. So the last thing is true, but this is overall this is incorrect, okay? Because this is not the true statement. Because the first set is linearly dependent, okay? And the second says that if A is a singular matrix, then this set spans the K plus 1 dimensional subspace of V for all K greater than equal to rank, less than equal to rank K. So any one of you can solve it? I would happy if you will tell the solution very quickly. First, you have a singular matrix, right? So let me give you some hints. Then the rank of A means n minus 1. It says that whenever you consider such a set, I mean, any k less than equal to, I mean, if the rank is exactly n minus 1, okay? So you can take some example. Okay, Ritika.
So
Yeah.
zero matrix.
So for zero matrix, I mean, you don't have any k, I think. I mean, I will span definitely. Oh, okay. हाँ, बताओ.
Since we have given that A is a singular matrix, so determinant A का 0 होगा, so rank जो होगी वो जितने ऑर्डर की मैट्रिक्स है उससे कम होगी. जब मिनिमल पॉलिनोमियल की हेल्प लेके हम उसको दिखाएंगे कि ये मिनिमल पॉलिनोमियल को सेटिस्फाई करेगा, तो फिर वो मतलब उसमें जो ऑर्डर आएगा वो k से छोटा ही होगा, तो बाकी जो उससे कम ऑर्डर होगा मैट्रिक्स के ऑर्डर से, तो वो li होंगे. ऐसे करके ले सकते हैं सर, या फिर हम
Okay,
ऐसे
okay.
कर सकते हैं कि एक मैट्रिक्स फॉर्म कर, जैसे उसकी
ठीक है,
रैंक
ठीक है,
अगर
ऐसे
8
कर सकते
की
हैं.
आई है तो उस ऑर्डर की हमें एक मैट्रिक्स मिल जाएगी, सब मैट्रिक्स, तो वो
ठीक है.
li फॉर्म करेगी.
Right. चलो ठीक है, तो फिर n इक्वल टू 4 लेते हैं और यहाँ पे 0 रख देते हैं. ठीक है, इसकी मिनिमल पॉलिनोमियल क्या है? ओके, सो द मिनिमल पॉलिनोमियल ऑफ दिस इज x minus 2 into x, right? So it means A is satisfying C, this, right? Okay, also all these are, this is linearly dependent. Can any, sorry, linearly dependent. आप बता सकते हैं? Could you tell me why? So let me tell you some result, okay? The dimension of this space. So try to verify it at home. A to the power k, k is greater than or equal to 0. Dimension of span. Dimension of this is exactly the degree of minimal polynomial. Okay, degree of minimal polynomial of A. Okay, so this is linearly dependent. Why? Because see, any power of A which is greater than or equal to 3 can be written as a linear combination. See, I mean to say you have A square equal to 2A, right? So you can write A cube also in terms of A. So everything can also be written in terms of A. So I and A is linearly independent, but A square A cube, this is linearly dependent set. So here rank of the matrix is C, 3, and this set 1A, A square A cube sponsor two-dimensional subspace, right? The dimension of it is 2. So do you understand or not? Ask me if you don't understand. Do you have any questions?
यस सर, ऑप्शन
Yeah,
बी
please
के
ask.
लिए सर हम
हाँ, एक मिनट.
सर
हाँ,
ऑप्शन बी के लिए सर हम कोई भी नील पोटेंट मैट्रिक्स रैंक आर का ले सकते हैं.
Okay. I mean, I mean to ask that, do you have some question in this? Yeah, you can take, I mean, there exist infinitely many examples, okay? You can take a lot of examples. आप ले सकते हैं nilpotent भी, या कुछ और भी ले सकते हैं, अन्य चीजें ले सकते हैं, okay? So yeah, another question, someone asked something.
Again, repeat this second.
Yeah, the second thing is that I have taken the example of this matrix, right? This is a singular matrix C, and the rank of this is 3, right? Okay, this satisfies this because the minimal polynomial of this matrix is this, x minus 2 into x. So minimal polynomial will annihilate A. So A square is equal to 2A. I mean, all A square and A cube can be written in the linear combination of A and I. Okay, so this set is linearly dependent, right? Yes or no? See, A square equal to 2A, then A cube can be written as A square into A. Then in place of A, you will write 2A. Then again, it comes out to be 2A square. Then A square will be replaced by 2A again. Then you get here 4A. So everything can be written as a linear combination of I and A, any power of A. So this means this is a linearly dependent set and its dimension is 2, right? Because we have only 2 linearly independent vectors. So, but according to the question that whenever you take a k less than equal to rank A, then you get a k plus 1 dimensional subspace. But ऐसा यहाँ नहीं है. But this is not so like. So we should get a 4 dimensional vector subspace, but that is not like that. We are just getting a 2 dimensional subspace. So this works as a counter example. Okay. And you can use many things. Okay, just take some nilpotent matrix, something else. I mean, a lot of examples could be used. Okay.
Yeah.
So yeah. Okay. So let's proceed. This says that the sets both span the same subspace, right? This is very true, right? Because you know, see why? Because all these powers, a n to the power n plus 1, a n plus 2, dot dot dot, a n square already belongs to the span of this by Cayley-Hamilton theorem. Okay. Why? Because from the Cayley-Hamilton theorem, you get a n equal to some linear combination of I a dot 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 a to the power n minus 1. So for a to the power n plus 1 can also be written like a n into a. So eventually you write it as a linear combination of I dot 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 a to the power n minus 1. Okay. So all these belong. So if you, I mean, first you take the span of this set and then you are adding other vectors, then you get the same vector space again, right? I mean, because they are already in the span. Is it clear or not? Right. And the set is linearly dependent. It's the linearly dependent and we already have solved it. So this is also true. Okay. So the first and 1s2 is wrong and the third and fourth is correct. So any questions? No. Okay. So let's solve something quickly, okay? Without writing, just try to solve it. Okay, let us try to solve some questions very quickly because we have few minutes. Oh, no, we have, I mean, half an hour. Okay, so let's solve these questions. Okay, so let me give you now what I will do, I will give you 2 minutes for 3 minutes for question. Then I will tell you the quick way of solving them. Okay, very quick way. So let's start with these questions. So can you solve the 65 and 66? Try. You try first. Try to understand what they says and try to solve and raise your hand if you are done. Okay. Okay, so let me tell you the first one. Okay, so the question number 65, it says that f is R to R be a continuous function such that fx equal to 0 for all x outside the interval closed interval 0 1, right? It says that fx is the 0 function whenever for all x outside 0, 1, right? Is it clear from the question? Okay, and we
Open
are
interval
given
0.
open interval for all x less than equal to, yeah, thanks, open interval 0, 1. Okay, so the fx is given to be sum n tends to minus infinity to infinity f x plus 1. So this is a finite sum. Okay, you have to keep in mind that this is a finite sum. You have to observe it. If you observe it, then you will solve it very quickly. Okay, so this is a finite sum. Why this is a finite sum? Suppose that you see this as a real line. Okay, so this is 0 here, this is 1 here. Now fix a x, any x. Okay, any x. So this is a, so your a is here. So say a plus 1 comes out to be 1, and a plus comes out to be, a plus 2 comes out to be 2, and there is exactly 1 a plus n, right? I mean, it cannot be possible that a plus 2 is here, a plus 3 is here, or something a plus k is here. So suppose that a plus 2 falls here, then a plus 3 will be definitely outside. Do you understand this? This may be possible. Sometimes this may be possible that a plus something comes out to be 0. And oh, right, we are considering the open interval 0, 1, right? So anything, I mean, there is exactly one number inside of the form a plus something inside. So when you consider this sum, I mean a plus 1 f of a c f of a plus 1 dot 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 and f a minus 1 dot dot dot, because exactly 1 will be non-zero. In our case, a plus 2 is non-zero, then these all are 0, right? So that sum comes out to be, in our case, a f of a plus 2, right? This sum is finite. So no need to worry about convergence and all, right? So do you understand this is well defined? I mean, in the exam, definitely you should understand that this is well defined, but when you are solving it at home, then you should understand everything, right? So this is a well-defined function. And one thing you need to observe that this is a periodic function. Okay, why? Because if you see x plus 1, f of x plus 1, this comes out to be f to infinity and f x to n. You will write here n plus 1. Okay, so then as n varies over integers, then you know that this is again this, right? There is no difference, right? I mean, as n varies over integer, n plus 1s also take all those values, right? What n takes. Yeah, so it means it is a periodic function. Only one thing you need to verify, that this is a continuous function. So let me leave it as for you. And this is very clear, right? That f is bounded. Yes or no? This is very clear because f of r is just inside f of continuous function closed interval 0, 1. Yes or no? Because a continuous function maps compact sets to compact sets. So it means that this is a compact set, and every compact set in real line is a closed and bounded set, right? So this comes out to be something like this. Okay? Yes or no? Yeah, I think, is there any question here? You can ask me that how this happens. I will elucidate it again. Is it clear? Right? So f is bounded. So verify that f is continuous. Okay, it's periodic. That's not difficult to verify. Only you need to check that one thing you have to keep in mind. Okay. So sometimes, I mean, you know that your function, just see that what is the value of function. Okay, let me tell you something. Suppose that you have a periodic function f, and in R, okay, R to R. I mean, in general, I'm telling you, okay, forget about it now, that you have a periodic function and you have with period 1, and you have given just values of fx in the closed interval 0, 1. Okay, so if the function is continuous in closed interval 0, 1, it may not be continuous everywhere. Okay, so one needs to check the like the fractional part. If you see, fractional part had period 1, right? So you need to check that at the endpoints the value is same. Okay, this is only thing you need to check in case of periodic function. Once you know the value, what it is, what the values it is taking inside in the closed interval 0, 1, then verify that at the endpoint the graph matches. Okay, so let me leave it as, for you. Okay, if you don't understand, then what I said that in the YouTube channel, what I have told you in mathematics, just go to the playlist, you will find the complete and very detailed solution of it. Okay, so and every periodic continuous function is always uniformly continuous, right? I think all of you know this. Yeah.
Yes.
So this one is wrong. So, and this you must know, because in the previous year exam of, I think, December 2023 or something around that, there is a question where we use that periodic continuous function is uniformly continuous, and this is very well known result also. If you have read the books of real analysis, you must have seen this exercise as an exercise or as a theorem in the book. Okay, so let's solve the next one now. So do you have any questions, by the way, in this what I have told now? I mean, don't consider this question as a difficult one in the exam. Okay, these kind of questions should be solved. And let me tell you something which can help you to score good in exam, that in the NET exam you have a lot of options. You must have read your full of syllabus, and if you are fully prepared, then you have to pick those questions which can be solved easily. Okay, don't engage yourself with difficult on longest question, where you have to solve a question, then you get answer. I mean, the solving, I mean, it has very lot of steps, like in the applied mathematics. I'm not saying that you should not solve from applied mathematics. You should solve definitely, but only those questions which can be solved very quickly, because you have other options in the exams also, right? Real essays, though, I mean, pure mathematics, in the pure mathematics, you can solve questions very quickly. No, I mean, there will be some question which cannot be solved very quickly in the exam also, but you know, the weightage of your mathematics, abstract algebra, complex analysis, reanalysis, and linear algebra is very high. Okay, and this is all I'm saying in my from experience. Okay, this is not a generic advice, let me tell you. Okay, so this one, uh, so how many of you could solve this one? By the way, I had given you the time to solve it. Could you raise the hand? Okay, try it if you couldn't. Okay. Only 3. So this question should also be solved very quickly in the exam. Okay, try it now. Once again, try it. Okay, let me give you a hint that you could use which theorem? Leibniz rule of differentiation under the sign of integration. Okay, you could use that. This is a hint for you.
So isn't it fundamental theorem of calculus?
Yeah.
But you said that Leibniz rule, but isn't it is a
Yeah, I
fundamental
know
theorem
it
of
as a
calculus?
Leibniz rule. When you differentiate, I mean, fundamental theorem of calculus says that, I mean, you know, for definite integral a to b, then if it has an antiderivative, then its value will be fb minus fa. Okay, don't worry. I just saying that differentiate this function. You should know that this is a differentiable function and you can differentiate. There is a rule. Just use that. Okay.
Okay.
Okay, I am happy that many of you have solved it. निधि बताओ कौन सा सही है?
ABC.
Okay, ABC ठीक है. Okay, so let me tell you. See, so one thing you need to know that suppose that you have a function f, okay, close interval say ab to r, and which is Riemann integrable, then you can consider this function, right? Let's take here, okay, a to x ft dt. This function is well defined and this is differentiable wherever f is continuous. Suppose c is a point inside AB, then if f is continuous at c, then this function is differentiable at c. Okay. So
Yes.
this I mean theory of Riemann integration tells this. Okay. So you should know that first. Now, suppose that you have a continuous function from closed interval AB to R, then this function is always differentiable. Okay. This function
Yes.
is always differentiable. Then, and its derivative is nothing but f. Okay. Yeah. So now see that g is given to be a continuous function, right? So for for every interval of the form 0 to y, say that x is between the, this is well defined. Okay, so it is well defined for each x, because a continuous function is always Riemann integrable on closed and bounded intervals. So, and if g is continuous, then obviously for fixed x, okay, suppose that x is fixed, okay, let's replace this by a, then a minus t gt is also continuous function, right? If g is a continuous function, because this being the product of two continuous functions, so it is continuous. So your function, defined function, is everywhere differentiable in R. Now let's do the differences. So f0 is very clear to see that 0 0 minus tgt. So this comes out to be 0, right?
Sir.
Okay. हाँ बोलिए. अच्छा. Okay, you can mute yourself. Okay, I thought that is some question. Okay, so now first we need to find f dash x. So let me know what is f dash x. 0 to x del by del x. I'm using the Leibniz rule. Okay, I
F
hope
dash
that
is
you know.
equal 0.
F dash x, not f dash 0. I'm asking f dash x. Okay.
Okay.
So yeah. Now you have to put 0 in place of
T.
t. So when you put this, comes out to be. So what it comes out to be?
Other 0 हो
0
जाएंगे.
plus 0.
0 plus 0 हो
0
रहा है?
दोनों. Yes.
ठीक है. Okay, let me not make the calculations. You will do that. So del by del x comes out to be 1. So this is gt dt, right? So f dash x is this.
Yes.
What I told you, that whenever some you have continuous function here, this is well defined differentiable function here. So f dash x is again differentiable. Okay, so here, from here you see that just like above, that f dash 0 is 0. So the second one is also true, and again the derivative of it, I told you here that g, okay, gx. So F double dash 0 is G0, right? So the third one is correct and the fourth one is wrong. I mean, this question could also be asked in the differential equation section. I mean, these kind of applied mathematics question you should solve. जिनको देख के पता लगे कि हाँ ये तो हो जाएंगे. You should not engage yourself with those questions which are very lengthy, because in place of them you can solve 2 or 3 questions. Okay, so yeah. Okay, so let's take some complex question. Okay, let me tell you something interesting. Okay, I forgot to take that question actually. Okay, so I will take that tomorrow. Okay, so a question in complex. I mean, sometimes you can use your smartness to discard the options and eliminate the options other than mathematics, a common sense. Okay, that is also used. So, but not here. Okay, in the other question I have seen. So I will discuss that question tomorrow. Don't forget to join the tomorrow's class. So, okay, try to solve this. Okay, so let me tell you the solution. Okay, how to solve it quickly. See, I mean, I'm wondering, actually, some of you should solve it. I know those one, okay, those student. Okay, so okay, so Piyush, which one is correct?
A, B, C.
Okay. If A is correct, then you must say C, right? And okay, by the way, suppose that तुमने सोचा कि चलो तुक्का लगा लेते हैं, A लगाओगे तो फिर B और C भी जरूर लगाना, ठीक है? I mean, this kind of common sense. I'm not saying that you should ये तुक्का उक्का मारना चाहिए, ऐसे नहीं बोल रहा हूँ, but just saying कि इतना तो पता होना चाहिए, okay? You should know at least this. That F is constant, then definitely it has removable singularities and it is bounded. Okay, and you should leave the D. Okay, yeah. Okay, so let's start. So if I able to prove that F is constant, then everything is, I mean, full question is solved. Okay, so let's see. See, you have a function from this C to where we have removed -1 and +1 to C. Okay, and it is not taking the values inside open unit disk, right? So let's see that what singularities at -1 and 1 it can have. No no essential singularity, right? Why? Anyone?
Causative discharge. Causative
Ah.
discharge.
Right. Because F does not have dense image. Dense image. Right? Because if you have a function, say, from a domain and you have a singularity at some point, then you see that the image of that domain comes out to be dense, right? Because of the Kajority-Weierstrass theorem. You all know that, I think. Okay? And not a pole. And I would be happy if you can discard that. Why? Not a pole.
Because of Riemann, because the theorem on poles that कोई भी any function cannot take taking more मतलब leaving more than 2 values is constant.
No, not more than
So-
skipping 3 values, I think.
Uh-huh.
Right? At
3
most,
values
yeah,
is
yeah,
a
right,
constant.
right. Yeah. So let me tell you, the Picard, I mean, I don't know what this theorem is called. Picard theorem for meromorphic functions. Why this is a meromorphic function? Okay, suppose that we have already eliminated that this possibility of essential singularity. Now your function can only have poles. Okay, if it has a removable singularity, then we can remove that. Okay, don't worry a bit about that. So, and it is skipping so many values, and a meromorphic function, suppose that it has a removable singularity at 1, then it's fine. It has a removable singularity at -1, then it's fine. That then we get removable singularity at -1 and 1, and we can remove that. Then f must be constant. I will let you know why that. But I am claiming that, okay, so it does not have essential singularity. Say that it does not have a removable singularity. So if it has a removable singularity at one point, then just you remove. Then you leave with a you left with a meromorphic function that is either from 1 point here or 2 point here. Okay, so that image of that meromorphic function not comes out to be dense. Okay, the image of a meromorphic function is also dense. Okay, right? Yeah, right. Okay, so it cannot have a pole. यहाँ पे मैं लिख देता हूँ, image of meromorphic functions is dense. It's dense. So it means that F has removable singularities. But if F has removable singularities, then we can extend F to be an analytic function from C to where? Still C/D, right? So many of you may think that, okay, sir, at -1 and 1, it can take some values inside D. No, that's not possible, because the image of a continuous function, image of the connected set under a continuous function is connected, right? Even if the singularity is removable, then the image will comes out. I mean, the values at -1 will be outside the disk. Okay, so you see that this entire function is skipping too many values, right? And the Picard theorem says that it can skip only 1 values. And this entire function does not have the dense image. What does it mean? That this entire function must be constant. When you extend your f to c, then that comes out to be constant. So it means that f, when restricted to this, is also constant. So it means f is constant, and this b and c is automatically true, and it is wrong, right? Yes or no? Is it clear? Or do you have some questions? No questions? Okay. Right. So let me solve this one quickly, okay? Okay, so do you want to try? Let me know. Actually, tomorrow I will send the questions in advance, okay? So that you can solve all the questions at home before coming to the session. I could not solve today. Yeah, Abhishek, do you want to ask something? I think you are trying to speak something, but your voice not coming. I'm not getting your voice. If you are trying to speak. Okay. So raise your hand, okay, once you're done. Okay, so let me tell you the solution. How you solve this question in the exam quickly. See here. You have given that fz equal to fij. Right? So here, first one is asking that fz equal to f of minus z. So f of iz. Iz is also a complex number, right? So this comes out to be I into iz, right? So this is minus z and we are done. This holds for all z, right? First one is solved. Okay, there is another way of solving this question by via power series, but you can do it more elementarily. Okay, so see, now differentiate both sides, f dash z, then you get I here, f dash iz. Okay, so can you tell me the general formula? Fkz equal to, if you differentiate k times, what do you get? I to the power k, yes or no? Is it correct or not? Yeah. So from here, what do we get? See, it says that f dash 0, f double dash 0, and f triple dash 0 is 0. See, if say, I mean, k is not a multiple of 4, say k is not equal to 4n, then we get here either minus I, either minus, I mean, three things we will get. Minus I, or minus I, right? Say that you get I. Okay? And put 0 on both sides. Okay, just put 1, 2, 3 in place of k, then you will get f1 fkz is 0 whenever put z equal to 0, whenever k is not equal to 4n. Do you understand this? I mean, this calculation you can do, right? आप कर सकते हैं ना ये?
सर मुझे नहीं आया.
हाँ, पूछिए आप, कहाँ पे नहीं आया?
सर जब हम लोग kth
यहाँ तक-
डेरिवेटिव ऑफ f of z जब
अच्छा,
0
यहाँ
रख रहे हैं,
यहाँ तक
सर
ठीक
वो
है?
तो समझ में आ
यहाँ
रहा
तक
है मुझे,
हाँ
वो आ रहा है. लास्ट जो
फिर?
कंक्लूजन आपने मुझसे निकाला वो नहीं आया.
हाँ, वो मैं आपको बताता हूँ. जैसे मान लीजिए आपने 2 पुट किया, राइट? 2 पुट करेंगे तो आपके पास यहाँ पे क्या आएगा? आई स्क्वायर आएगा, तो माइनस ऑफ, हाँ, माइनस ऑफ 2iz. अब 2 पुट करिए, अब यहाँ पे 0 पुट करिए z की जगह, तो आपके पास क्या आएगा? f डबल डैश 0, राइट? माइनस ऑफ f डबल डैश 0. So which number is equal to its negative?
Okay. By taking f double dash of 0 as a polynomial, we'll get rid of double dash of 0
right.
equals to 0.
वही.
Yeah, fine.
तो या तो यहाँ पे माइनस आएगा या यहाँ पे प्लस आई आएगा, माइनस आई आएगा, लेकिन whenever we get here 1, then we cannot comment, right? That will
Yeah.
give that f of 4 4 times 0 is equal to f of here 4 dash 0, right? So we cannot say anything. So it means that also if we, so first one is correct, second one is correct, and the third one is obviously wrong because one can take, it says that necessarily constant function, you can take z to the power 4, okay? Because, right, I to the power 4 is 1, right? And you get this idea of taking z to the power 4 from here, right? And also, when you expand it as a power series, then you know that only these are non-zero, right? 4k. So its power series looks like this. Do you understand? Okay, so now fz is like this. B z to the power 4 equal to, just assume w and get that fz is of the form gz to the power 4. Okay. You will do that calculation, right? Yeah, okay. So we have solved this one. Any questions, by the way? And this is the easiest one, okay? This is part C question. All these are easy questions. So today I will discuss some difficult questions also. So yeah, difficult questions need some time, okay? So what I told all you that you can go to the Ing Mathematics channel homepage, okay? Just go to the Ing Mathematics channel homepage all and watch all the CSIRNet previous year solutions, okay? All playlist has been listed there and the solutions are organized by their order ID. They are in order, okay? You can locate everything very easily, okay? So yeah, I think we should stop for today and we will meet tomorrow at the exact timing 7. Okay, so join 5 minutes earlier. Yeah, I should stop here. If you have any question, then you can ask. Or if you want to say something, then you are welcome.
Hello, sir.
Yeah.
Yes,
Yeah.
I am new here. Exactly, I am coming from in P Kalika Mathematics Group link.
Okay.
Yeah, these classes are held only for 2 days or tomorrow.
Yeah. Tomorrow you can also join.
Okay, and in the Telegram description, I am seeing some for June CSIR NET exam. I am seeing some crash course, something like. Can you provide some more
Which
information?
Telegram group? I mean, in the Ing Mathematics Telegram group.
Yes.
Yeah, then you can join the crash course of Ing Mathematics if you, if you wish, you can just check it in YouTube channel, all the information. You can go to the YouTube community post and check there. It starts on 4th July. Okay, so yeah, let's stop here, student, and let me stop the recording. Yeah.